Hello friends, I welcome you in lecture number 7 on counting. In this lecture we are going to discuss about Inclusion Exclusion Principle. It is also known as Subtraction Rule or Principle of Inclusion Exclusion. So we will discuss this principle and we will see one example related to this principle. Before going for Inclusion Exclusion Principle, we recall the sum rule for counting which we have discussed in earlier lectures. We know that we can apply sum rule for counting if we have suppose task T1 and task T2 which cannot be done at the same time. Once we are doing task T1, it is not possible to do task T2, and when we are doing task T2, it is not possible to do task T1. In short, if T1 and T2 cannot be done at the same time, then we can apply sum rule, and sum rule says that if n1 is the number of ways of doing task T1 and if task T2 can be done in n2 ways, then the number of ways of doing task T1 or task T2 is addition of n1 and n2. So this is sum rule, and it is applicable if we cannot do two tasks at the same time. But suppose we have a situation in which there are some common ways to do task T1 as well as task T2, or we can do task T1 and T2 at the same time for some number of ways. So in that situation we cannot apply sum rule. So for that we have to go for Inclusion Exclusion Principle or Subtraction Rule. So suppose there are n1 ways to do task T1, n2 ways to do task T2, and say alpha ways to do task T1 and T2. Okay, in alpha number of ways we can perform T1 and T2 at the same time. So in this situation we cannot apply sum rule. So for that we have to go for Inclusion Exclusion Principle. So Inclusion Exclusion Principle says that if you have some common number of ways such that you can perform both the tasks at the same time, then the number of ways of doing task T1 or T2 is given by addition of n1 and n2, that is number of ways of doing task T1, number of ways of doing task T2, minus common number of ways of doing task T1 and T2 at the same time. So we have to include the number of ways of doing T1 and T2, and we have to exclude the number of ways in which we can perform both the tasks at the same time. So we are excluding common number and we are including this n1 and n2 of doing task T1 and T2. So therefore this is known as principle of inclusion exclusion. So whenever we have some common number of ways of doing task T1 and T2, then we will not go for sum rule, we will go for principle of inclusion exclusion. So first we have written this principle, Inclusion Exclusion Principle or Subtraction Rule. This is another name, Subtraction Rule for Inclusion Exclusion Principle. If a task can be done in either n1 ways or n2 ways, then the number of ways to do the task is n1 plus n2 minus the number of ways to do the task that are common to the two different ways. So we will exclude the common number. Okay, I think this will be better to understand. Suppose task T1 can be done in n1 ways, task T2 can be done in n2 ways, and both tasks can be done at the same time in alpha number of ways. Then the number of ways of doing at least one of these two tasks, or number of ways of doing T1 or T2 is equal to N1 plus N2 minus alpha. We understand this principle with this example. How many bit strings of length 8 either start with a 1 bit or end with 2 bits? So here we have a problem of constructing a bit string of length 8, and that bit string either start with a 1 bit, that is first bit of the string is 1 and the last 2 bits of the string are 0. So first we understand this question. Here we are asked to construct a bit string of length 8, and in how many ways we can construct a bit string of length 8 such that first bit is 1 and last 2 bits are 0 0. So we have this type of situation. Suppose I consider this string of length 8, 1 2 3 4 5 6 7 8. Suppose I consider task T1 as constructing a bit string whose first bit is 1. First bit is fixed, it is 1. And suppose we consider task T2 as a bit string of length 8 whose last 2 bits are 0 0. That is, bit number 7 and 8 are 0. Now if you look at the question, if we define T1 as string whose first bit is 1, if we define task T2 as that string whose last 2 bits are 0 0, then if you understand this question in this way, then here we are asked to find out the number of ways of doing task T1 or task T2. We have denoted task T1 as a task of constructing bit string of length 8 that start with first bit as 1. This is task T1. And T2 denote the task of constructing a bit string whose last 2 bits are 0 0. And here we are asked to find out that how many bit strings of length 8 either start with a 1 bit or end with 2 bits 0 0. That is, we are asked to find out the number of ways of doing task T1 or task T2. So we have denoted task T1 as a bit string of length 8 whose first bit is 1. Task T2 is a bit string of length 8 whose last 2 bits are 0. That is, bit number 7 and 8 are 0 0. Task T1 is first bit is 1. And our aim is to find out number of ways of doing task T1 or T2. So here if you observe, there are some number of ways in which we can perform T1 and T2 at the same time. We can construct a bit string whose first bit is 1 and last 2 bits are 0 0. So that type of bit strings are also possible. So here we have to find out the number of ways of doing task T1 and T2 at the same time also. First we will find out the number of ways of doing task T1. So task T1 is constructing a bit string of length 8 whose first bit is 1. And we know that if we want to construct a bit string, we have two possibilities for each bit. Each bit can take the values 0 and 1. So there are two ways of selecting each bit. Now for T1 we have to fix first bit. First bit is 1. So first bit can be selected in only one ways. So the number of ways I am writing here, because T1 is the task of finding a bit string starting with first bit as 1. So we can select first bit in only one ways. Now there is no restriction for the remaining bits. There are 7 remaining bits and each bit can be selected in two ways. You can have 0 or 1 for second bit. Similarly, third bit can also be selected as either 0 or 1. So for the remaining bits there is no restriction. So each of the bit starting from second to 8 can be selected in two ways. And constructing a bit string of length 8 starting with 1, that task can be done as combination of all these tasks. So here we have to apply product rule. If we want to construct a bit string of length 8, we have to choose each bit, and each bit can be chosen in two ways, and all these bits are necessary to construct a bit string of length 8. So we have to multiply this number of ways of choosing bits. So here we are applying product rule. By product rule we can do task T1 in 1 into 2 into 2. Here we have to multiply 2 7 times. 1, 2, 3, 4, 5, 6 and 7. 7 bits can be chosen in two ways. First bit can be chosen in one way. So we have 2 raised to 7, that is 128 ways in which we can do task T1, or we can have 128 bit strings of length 8 whose first bit is 1. So the number of ways of doing task T1 are 128. Now similarly we find out the number of ways of doing task T2. So in task T2 we have to construct a bit string whose last two bits are fixed, that is 0 0. So now instead of this situation, or we can write here, for task T2 we have this type of situation. Suppose this is a string 1 2 3 4 5 6 7 and 8, and for task T2 we have to fix last two bits. So last two bits must be 0 0. Now for remaining bits we have two possibilities, because each bit can be 0 or 1, and for these two we have only one ways. So again by the product rule, task T2 can be done in 2 into 2 into 2, 2 into 2 into 2. There are 1 2 3 4 5 6. We have to multiply 2 6 times. Here there are only one ways possible. So this is equal to 2 raised to 6, that is 64 ways. There are 64 bit strings of length 8 that end with 2 bits as 0 0. So the task T2 can be done in 64 ways. Task T1 can be done in 128 ways, because for task T1 first bit is fixed. So we can select that first bit in only one way, and remaining 7 bits can be selected in two ways. So by the product rule we can have 2 raised to 7, that is 128 ways of doing task T1. For task T2 we have last two bits 0 0. Last two bits are fixed here, they must be 0 0. So we can select this last two bits in only one way, and remaining bits starting from 1 to 6 can be selected in two ways. Therefore by the product rule, task T2 can be done in 2 raised to 6, that is 64 ways. Now we have to count the number of ways that are common to both the tasks. That is, we have to count. First let me write this 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Now we have to find out the number of ways in which we can perform T1 and T2. we have to find out the number of bit strings such that first bit is 1 and the last two bits are 0 0. So that are the common number of ways in which we can perform T1 and T2 at the same time. So for T1 we have to fix first bit as 1, not 0. First bit is 1 for task T1. For task T2, last two bits are fixed, they are 0 0. Therefore we can perform we can choose first bit in only one way. Similarly, we can choose last two bits in only one way, and remaining bits starting from second to 6 can be selected in two ways. There are two possibilities for each bit, either 0 or 1. So now we have to multiply all these number of ways. We have 2 into 2 into 2 5 times, so I write directly 2 raised to 5 into 1 into 1, that is 2 raised to 5, that is 32 ways. In 32 ways we can construct a bit string of length 8 starting with first bit as 1 and ending with last two bits as 0 0. So you can see there are common ways in which we can perform task T1 and T2. So now we have everything which we require for inclusion exclusion principle. We are interested in the number of ways of doing task T1 or T2. So by the inclusion exclusion principle, this is equal to number of ways of doing task T1 plus number of ways of doing task T2 minus number of ways of doing T1 and T2 at the same time. So here this is just for understanding T1 and T2. T1 can be done in 128 ways. We have obtained these figures. T2 can be done in 64 ways, and T1 and T2 can be done in 32 ways. So if you do these calculations, you will obtain 160 ways in which we can do task T1 or T2. That is, there are 160 bit strings of length 8 that either begin with first bit as 1 or end with last two bits as 0 0. So this is very nice application of inclusion exclusion principle, and you have to write down all these things systematically. I have written all these things here. So we just again take a look at this example, how to write or how to answer this type of questions systematically. How many bit strings of length 8 either start with a 1 bit, that is first bit as 1, or end with the two bits 0 0. So first observation we must have about this. Here we have OR type situation. So whenever we have OR type situation, we will have either sum rule or inclusion exclusion principle. So here from this OR we break this into two parts. We have to construct bit strings of length 8 that begin with first bit as 1, and we have to consider bit strings of length 8 that end with two bits as 0 0. So from this OR we can decide that we have to consider which two tasks. So I have denoted task T1 by task of constructing a bit string of length 8 beginning with a 1 bit, or first bit is 1. So if first bit is 1, then it is possible that we can select it in only one ways, because first bit is fixed, first bit must be 1. So there is only one way to choose first bit. The first bit can be chosen in only one way. There is no restriction on the remaining 7 bits. They can be chosen in two ways, either 0 or 1. So and each of the other 7 bits can be chosen in 2 ways. Therefore, by the product rule, the number of ways of doing task T1 are 1 into 2 into 2 7 times, that is 128. Then task T2 is constructing a bit string of length 8 ending with 2 bits 0 0. So here last 2 bits are fixed 0 0. So we can select last 2 bits in only one way, and remaining bits starting from 1 to 6 can be selected in 2 ways. So here we have to write each of the first 6 bits can be chosen in 2 ways. These 6 bits can be chosen in 2 ways. They can be either 0 or 1. And the last 2 bits can be chosen in only one way. There is only one way to choose last bit, because it must be 0. Similarly for 8th bit. Therefore, by the product rule, task T2 can be done in 2 into 2 6 times into 1 into 1, that is 2 raised to 6 equal to 64 ways. So first we have obtained the number of ways of doing task T1, then we obtain the number of ways of doing task T2, and now we write the number of ways in which we can do task T1 and T2 simultaneously, or we find the number of ways in which T1 and T2 can be done at the same time. So both tasks T1 and T2 can be done at the same time. For that we have to construct a bit string in which first bit is 1 and last 2 bits are 0 0. So now first bit is fixed, it is 1, so we can select it in only one way. Similarly last 2 bits are also fixed, therefore they can be selected in only one way, and remaining bits starting from 2nd to 5 can be selected in 2 ways. For each of the remaining bits there are 2 possibilities. Bit can be 0 or 1. So there are 2 ways of selecting bit number 2 to 5. So the first bit can be chosen in only one way. Each of the 2nd through the 6th bits, 2nd, 3rd, 4th, 5th and 6th, up to this we have 2nd to 6, can be chosen in 2 ways. The last 2 bits can be chosen in only one way. Therefore the number of ways of doing both tasks T1 and T2 are 2 raised to 5, that is 32 way, and this is by product rule. Hence we have obtained the number of ways of doing task T1, which are 128, the number of ways of doing task T2, which are 64, and the number of ways of doing both T1 and T2, which are 32. So therefore by the inclusion exclusion principle, the number of ways of doing task T1 or T2 is equal to number of ways of doing T1, which is 128, plus number of ways of doing T2, which is 64, minus number of ways of doing T1 and T2 both, and there is 160 answer. So there are 160 bit strings of length 8 that begin with a 1 bit, that is begin with first bit as 1 or end with last 2 bits as 0 0. So in this way, if we have a situation in which we are asked to find out the number of ways of doing task T1 or T2, and if there are some ways in which we can perform T1 and T2 at the same time, then we have to apply principle of inclusion exclusion. We have to include the number of ways of doing T1 and T2, and we have to exclude the number of ways that are common to T1 and T2. So this is all about inclusion exclusion principle. I hope you understand this. I have done my best to explain this principle. If you have any doubts, you can ask in comment section. Thank you.